Welcome to Meaningful Magical Math. Today, I want to show you how to use the identity property of multiplication to make equivalent fractions. Now, you may not have heard of the identity property of multiplication before, but you actually already know about this mathematical property, even if it seems unfamiliar to you. Let me show you what I mean by doing a couple of practice problems or so. What if I start with this? 4 times 1. Do you know what that is? Of course you do. 4 times 1 is 4. We know that. And we are going to see that any time we multiply times 1, we're going to get the same thing we started with. The identity of the number we started with doesn't change. What about something a little larger, 256 times 1? Do you know that? Well, of course you do. It's 256 because, of course, anything multiplied times 1 does not change. The identity is still the same. All right, let's be goofy. What about heart times 1? What would that be? Well, of course, because we're multiplying by 1, this identity doesn't change. So, of course, heart times 1, if there is such a thing, is heart. Multiplying by 1 is what mathematicians call the identity property of multiplication. And this property, as you already see, says that anything times 1 is that thing. In other words, the identity of a number that we multiply by 1 doesn't change when you multiply by 1. All right, now let's take this simple property of multiplication and help us use it to understand how it works to find equivalent fractions. So let's start with a fraction. Let's say 1/4. 1/4. And then we're going to multiply 1/4 by another fraction that's equivalent to 1. So we're going to multiply 1/4 by another fraction that's equivalent to 1. How about I draw a great big number 1? This will symbolize a fraction that's equivalent to 1. And we should, because we understand the identity property of multiplication, we should get the same identity. All right, so now, first of all, you heard me say find an equivalent fraction to 1/4. What is equivalent? Equivalent is equal to or the same. So if we multiply 1/4 times 1, the identity property, again, tells us that we should get 1/4 or the same identity that we started with. So let's multiply 1/4 by, let's say, 2/2. Now, you're probably wondering, is 2/2 1? You're probably wondering this. Is that 1? Well, let me show you with a simple picture. We know 2/2, 2 halves, is a whole divided into 2 pieces, right? That's the denominator divided into 2, and this tells us how many pieces are shaded. So let's see, let's use a different color here. So we see 1 half shaded and another half shaded. 2 halves totally shaded. And isn't this 1 whole? It sure is. So 2 halves is equal to 1 whole. So when I put it up here in my 1, we know that 2 halves is the same as 1 whole. So we are using 1 here. We're just naming it as 2 halves. So let's go ahead and do the math. Let's do the numerator 1 times the numerator 2. We will get 2. And let's do the denominator 4 times the denominator 2, and we will get 8. So 1/4 is the same as 2/8. Let me see if I can show you a picture of that. Let me erase all this picture work, if I can, and show you that 1/4 that we started with. That's 1/4, right? Those are divided into fourths, so here's 4th. All right, let me take a different color and divide this into 8ths. All right, do we see 8ths? 1, 2, 3, 4, 5, 6, 7, 8. Now, of course, my drawing isn't very clear, but we see that 2/8 right here is the same as 1/4 that I started with. So yes, 1/4 is equivalent to 2/8. It is the same identity. All right, let's try another example. What about 2/3? Why don't I multiply that times 1, use the identity property here, and we should get the same identity, right? 2/3 multiplied by 1 should give us 2/3, or at least an equivalent fraction to 2/3. So this time, let's multiply 2/3, not by 2/2 that we did up above, but how about like 4/4? Is 4/4 1? You're probably wondering, is 4/4? Is that 1? Well, let me draw you a picture. Again, I'm very good at drawing. I'm sure you've already noticed. All right, there's fourths. So 4/4 is 1/4, 2/4, 3/4, 4/4. Yes, absolutely 4/4 is the same as 1 whole. All right, so here we have in fact multiplied, or we're about to multiply 2/3 by 1 whole, 4/4. So let's go ahead and do the multiplication. The numerator 2 times the numerator 4 is 8. The denominator 3 times the denominator 4 is 12. So we've just shown that 2/3 is equivalent to 8/12 because we know that, because we know the identity property works. Well, this is awesome. Knowing we can multiply any fraction by 1 helps us find an equivalent fraction with different numerators or denominators that have the same identity as the fraction we start with. So let me show you what I mean. What if I start with 1/5 and I want to find an equivalent fraction to it that has tenths, that is broken into 10 equal parts, not 5 equal parts, but this time 10 equal parts. Well, what would that fraction be? Well, we can use what we know, the identity property of multiplication, to determine what times 1/5 would equal tenths. Well, let's take a look at our denominator. 10 times what? This is a fraction. 10 or 5, I think I said 10. 5 times what would equal 10? Well, we know that that would be 2. 5 times 2 is 10, and because this has to be 1 whole, we better call this 2 over 2, 2 halves. And now let's go ahead and multiply our numerator times our numerator. 1 times 2 is 2. So 1/5 is the same as 2/10, and we know that because we've practiced the identity property. Okay, let's try another example. How about 3/8? What if this time I want to see how many eighths, what is the equivalent fraction to 24ths? How can I turn 3/8 into something that has 24 equal pieces? We know that this should be equal if we use the identity property. All right, let's see. Well, let's look at our denominator, 8. How are we going to get to 24ths? Well, we're going to need to use an equivalent fraction to 1, so let's see. 8 times 3, I know, is 24. So this fraction here, equivalent to 1, must be 3/3. 3 times 3 is 9. So we have 3/8, which is equivalent to 9/24. All right, what if, let me pull this back up. All right, what if instead of a denominator, I want to find a numerator, a missing numerator? What if I start with 8 somethings and I want to turn 4/6 into 8 over something? What would that denominator be? All right, let's see. Well, remember, we're going to multiply times 1 whole, And if we do that, we know that multiplying times 1 whole is the identity property of multiplication, and 4/6 will not change. Okay, so let's go ahead and let's think about what times 4/6 would equal 8 over something. Well, let's think about our fraction. 4 times, the numerator 4 times what equals 8? That would be 2. And so we know this must be 2 over 2 because in order for this to be 1, it has to be 2 over 2. So 4 times 2 is 8, so the denominator 6 times 2 is 12. Now, I've given you several examples to prove that using the identity property of multiplication will help you find equivalent fractions. I hope that this has helped you understand this. And this isn't really magical, it's just mathematical.